We are going to have 20 billion low-power devices by 2020, which is, by the way, in 4 years. Let me tell you about some of those 20 billion. This is going to be our city in the near future. Every dot represents a wireless sensor network that requires just a little bit of power to do some important work for us. Think about Rotterdam. Every day, 30,000 containers are going through the harbor. Someone should know where they are and what is the temperature inside. It is important, for example, if that's a food container. Sensors can do that for us. They can locate themselves, and they can sense the temperature. Let's take another example. Every year, 60 to 80,000 wildfires happens in the United States only, which creates an extensive damage. This could be reduced if we could simply hang a sensor from a tree to detect a fire early on, such as a fire detection sensor in our houses. This tiny device in my hand is such a sensor. It requires 3,000 times less power than a mobile phone to do all this work for us. However, all would need batteries. And similar to a mobile phone, the battery will die one day. And this is bad for our environment. The disposed batteries for about 20 billion devices can fill as many as 1,000 Olympic-sized football stadiums until the ceiling. And battery replacement is even a bigger problem that costs our industry 7 billion euros to replace batteries every year for their efficiency, productivity, and safety. And is even more challenging for medical devices, because it's not only about the costs, but also risk to lives. Take a pacemaker. Every patient should go at least under 3 surgeries during their entire life to replace the battery which were meant to keep them alive. Motion is an essential part of our everyday life. Why not harvest energy from motion to power our devices? You may ask yourself how. We can use motion energy harvesters. They're basically like miniaturized electrical generator. They capture the kinetic energy and transfer it into a useful energy such as electricity. Continuous power is not necessary. Many devices even wouldn't need continuous power. While batteries has a limited amount of power that drains over time, energy harvesters capture the kinetic energy, transfer it into electricity, store it temporarily, and once it is needed, send it to a device. But they could do that for the entire life of a device. You may ask yourself, okay, that sounds great, why we don't see energy harvesters around? The problem is, energy harvesters until now could only work under regular and even motion. However, the real life is neither regular nor even. To give you an example about that, think about watches. Watches are one of the most human inventions towards regularity. Can you imagine to walk as precisely as ticking a clock? Does ships move as precisely as a watch? Does leaves of a tree move as precisely as a watch? Can a heart beat as precisely as a watch? Probably mine already beats faster than yours. And that's why we don't use energy harvesters so far. But we have found a way. We can design energy harvesters, can work under random motion. Think about a light switch. Yesterday's energy harvesters could only work under one motion setting. A light switch has an on and off position. So I'm talking about either on or off. However, a light switch has both positions. I would like to ask you, have you ever tried to place a light switch between on and off position? Maybe when you were a kid? That's almost impossible. But that makes it possible to create energy harvester that can work almost under any motion setting. This way, we can eliminate batteries. We can save 7 billion for our industries. We can avoid production line stop. We can avoid waste of batteries and their environmental problems. We can save lives. And beside that, we can make that possible for those 20 billion devices to come to create a safer and more efficient world. When I was giving a talk, I was carrying such an energy harvester with me. And I'm hoping I have generated enough power to power the sensor that I have shown you early on in my talk. Yes, you are seeing the signals, and if you could please tap on that. And now it shows that room temperature without using any battery, which is 22 degrees. So what has happened was, when I was giving a show, if you notice, I had a permission from TED organizers to cross the red carpet. So I create enough power to power the sensor, and now it is used, which gives me another chance to demonstrate again. Motion can power low-power devices. Once again, the room temperature, and I receive a cup of warm tea from the TED organizers. Let's see how warm or cold it is. As you can see, the temperature is going up, and I do think by now you believe I cannot deliver a regular motion such as a watch. So under real-life condition, we are powering the sensor. Temperature is going up, and it's really getting warm in my hand. Thank you. This is one of our 20 billion low-power devices to come that under real-life condition wouldn't need any battery. Thank you.